let v1 equal to 2, minus 1, 3, 2, v2 equal to minus 1, 1, 1, minus 3, and v3 equal to 1, 1, 9, minus 5 be three vectors of the space R4. We need to find whether the vector 3, minus 1, 0, minus 1 belongs to the span of the vectors v1, v2, and v3. Okay, so we start off by assuming that, so let's see the solution. So we start off by assuming that the vector 3, minus 1, 0, minus 1 belongs to the span of the vectors v1, v2, and v3. Now this implies that the vector 3, minus 1, 0, minus 1 can be written as a linear combination of the vectors v1, v2, and v3. Okay, so we can write 3 minus 1, 0, minus 1 is equal to alpha 1 times v1 plus alpha 2 times v2 plus alpha 3 times v3, where alpha i's, that is alpha 1, alpha 2, alpha 3, are constants. Okay, now this implies that 3 minus 1, 0, minus 1 equals alpha 1 times 2 minus 1, 3, 2 plus alpha 2 times minus 1, 1, 1, minus 3 plus alpha 3 times 1, 1, 9, minus 5. Okay, now this gives you that this is equal to 2 times 2 alpha 1 minus alpha 2 plus alpha 3, comma, minus alpha 1 plus alpha 2 plus alpha 3, 3 alpha 1 plus alpha 2 plus 9 alpha 3, and 2 alpha 1 plus, sorry, minus 3 alpha 2 minus 5 alpha 3. Okay, so this gives you a set of 4 equations, which are 2 alpha 1 minus alpha 2 plus alpha 3 equal to 3. So let's say this is 1. Then you have minus alpha 1 plus alpha 2 plus alpha 3 equal to minus 1. So let's say this is equation 2. The third equation is 3 alpha 1 plus alpha 2 plus 9 alpha 3 equals 0. So let's say this is equation 4. Sorry, let's say this is equation 3. And final equation is 2 alpha 1 minus 3 alpha 2 minus 5 alpha 3 equals minus 1. This is equation 4. Now for 3 minus 1, 0, minus 1, for this vector to be in the span of v1, v2, v3, these 4 equations should be consistent. Okay, now let us do some arithmetics here. So equation 1 plus 2 times equation 2 gives alpha 2 plus 3 alpha 3 equals 1. Okay, because alpha 1 cancels off. Similarly, you have that equation 3 plus 3 times equation 2 gives 4 alpha 2 plus 12 alpha 3 equal to minus 3. Okay, this implies that alpha 2 plus 3 alpha 3 equal to minus 3 by 4. Okay, now if you see here, you have alpha 2 plus alpha 3, 3 alpha 3 equal to 1 here, and alpha 2 plus 3 alpha 3 equal to minus 3 by 4. Okay, so we can say that from here we are getting 1 equal to minus 3 by 4, which is absurd. Okay, so therefore we have that the vector 3 minus 1, 0, minus 1 does not belong to the span of the vectors v1, v2, and v3.